Okay, so section 6.2 is about volumes using cylindrical shells. How do we do that? Again, we have a region that's made up of a curve like this, okay, bounded by this curve and also the x-axis, okay, and we want to rotate this around. X is equal to -1, x is equal to -1 is the red line here. And when you rotate it around that, you get a picture like that, okay. So in this case, we don't use washer, we use something else, spherical shells. All right. Okay. So how would you use a cylindrical shell? Okay, how would you do that? When you rotate the previous picture around x equal to -1, you get such a solid, right? And here, okay, so if you would see it, so we have the y-axis here, x equal to -1 here, okay. So we are gonna find we are gonna have cylindrical shells. These cylindrical shells are formed as follows. You are gonna have delta x. The width of the cylindrical shell is gonna be delta x. This delta x is gonna later on is gonna be converted to dx, and then we are gonna fix the kxk here and the corresponding yk. If you open up this and just a sec, be aware that we have this curve. Okay, this curve is gonna give us the y values. Okay, for example, for xk we are gonna have 3xk minus xk squared as the y coordinates, so the yk's are gonna change the height. Okay, and then we have the cylindrical shell. Now take the cylindrical shell and expand it. So this is the cylindrical shell. Cut it through here. Okay, and then if you open it up, you have this. It is like a matchbox. Okay, rectangular box, rectangular prism. And then so we are interested in finding the volume of this, and for each xk we are going to find the volume of this, and then we are going to add them up, kind of all these volumes to get the whole volume. Okay, let's try to find the volume of this box. As you would, okay, first of all, this cylinder has a radius, right? So what is this radius? Let's go back to here. Okay, this is -1. The radius of this cylinder is gonna be, there's 1 here and there's xk here, 1 plus xk. So the radius of this cylindrical shell is 1 plus xk. Okay, now we have the 1 plus xk. And the height of the cylinder is the y value, right? Which depends on this curve. So it's going to be 3xk minus xk squared. So now I know this is the height of the cylindrical box. I mean, rectangular box now when you open it up. And then this is the circumference of this circle. The circumference of this circle is 2 pi r. 2 pi, this is the radius, 2 pi r. And then the thickness is going to be delta x. It's very small, that's why it's called delta x. So let's find the volume of this. The volume of this is this times delta x times the height. Okay, and then we are going to integrate that over x. All right. Okay, it's the same. And this is how this explains how it is. So let's say this is the region, y is equal to f of x, and we form our delta x here, xk is fixed. We have a to b, and we have x is equal to l vertical axis of revolution, and so we revolve this around the vertical axis of revolution. All right. When you open this up, you get this. So 2 pi, this is the shell radius you find. So this is the circumference of this box. And then shell height is gonna, if you multiply it, you're gonna get And then if you multiply it with dx, delta x actually this is going to be the volume of this rectangular box. And then you integrate from a to b, you get the volume of the whole solid. Okay, that's how you would do it. Let's give another example. So this is the region that we have. This region is made up of y is equal to square root of x and y is equal to x-axis and x is equal to 4 line, right? And this is the region, and we want to rotate this around the y-axis. So how would you fix an x, and then at this x you can consider that you have a width with delta x, and then first thing you want to find is you want to find the radius of this cylindrical shell. The radius of this cylindrical shell is x. Okay, and then when you open up this shell, you have the length of the shell, which is going to form a rectangular box, and it's 2 pi x, and then we have delta x. Okay, and then the height, what's the height? The height is square root of x. So you multiply them all. Instead of delta x, you put dx and integrate over x 0 to 4, and you get the volume. Okay. Alright, so let's see. Next, we want to rotate this around x-axis. Our cylindrical shell, it's the same region, but we rotate around the x-axis. So our cylindrical shell is going to look like this. Okay. The first question is, what is the radius of the cylindrical shell? So if you look at here, it is this much is the radius, but it corresponds to the y. And what is y? You just write x in terms of y, it is y squared. So y squared is the, right? I mean, just a sec, square root of, let's see, let's go back to here. Right, if you rotate around the, about the x-axis, let's see. Here we rotate it around, right, around x is equal to -1. Okay, we get that. If you rotate around x equal to L, you have that. Okay, x equal to L, this is the formula, you get integration over x. But if you rotate around, okay, around y, this is going to be similar. Okay, and if you rotate around x on the other hand, okay, you're going to rotate around x, your shell is going to look like this. And what's the radius of this shell? So the height of this shell is how much? The radius is y, and the height is going to be the corresponding x value. I mean, what is x? This x square root. Let's see, shell height I'm interested in. Okay, alright, so the height is, so I stop at 4, right? So this is the total height, but I have to subtract this much height from it. This much height is y squared. Okay, x equal to y squared. This distance is x squared. Okay, this distance, I'm sorry, this distance is x. Okay, and then corresponding y is y squared. Okay, x is equal to y squared here because I'm interested in this x. So I have to write x in terms of y. So x is equal to y squared. So this distance is y squared. The total distance is 4. 4 minus y squared is going to give us the height. Okay, 4 minus y squared. So this is the height of the rectangular box. And the radius is y. So the 2 pi y times the height 4 minus y squared times delta y. But delta y, we are going to take it as dy. We integrate over y. And y is changing from 0 to 2, so that's it. Okay, it's going to give us the volume. Summary of the shell method. Regardless of the position of the axis of revolution, it could be horizontal or vertical. The steps are these: draw the region and sketch a line segment across it parallel to the axis of revolution. Label the segment's height or length and distance from the axis of revolution. Find the limits of integration for the thickness variable, of course. Integrate the product 2 pi shell radius, shell height with respect to the thickness variable x or y to find the volume. Okay, that's it.